All right, let's dive into the world of game theory. Today, we're talking about a really neat concept that helps us find the single most stable, most rational move you can make in any competitive game. It's a surprisingly elegant solution to what can be a very messy problem. Let's get right into it.
So here's the big question, right? When you're facing a smart opponent, how do you figure out the one move that guarantees you the best possible outcome, no matter what they decide to do? Well, believe it or not, the answer is kind of hidden in the shape of a simple horse saddle.
And I know what you're thinking. A saddle? But yeah, this shape is the perfect illustration for a point of strategic equilibrium. It's a point that's a high point and a low point at the same time, and that dual nature is the absolute key to finding stability in a game.
Okay, so let's really look at this shape. Imagine you're tracing a line with your finger from the front of the saddle to the back. You'd go up and over a peak, right? That's a maximum. But now trace a line from side to side. You're at the very bottom of a curve, a valley. That's a minimum. This one single point is both a peak and a valley, and that is the secret to strategic balance.
And this is exactly how it translates to game theory. A saddle point is an outcome in the game matrix that is the smallest value in its entire row, but at the same time, it's the largest value in its column. It's this perfect point where one player, who's trying to get the highest score possible, sees that their worst-case scenario is also the other player's best-case scenario. It's where their interests lock in. So we get the what, we understand the concept. But how do you actually go about finding one in a complex game with a ton of numbers? Well, thankfully, there's a really clever method for spotting this exact point of equilibrium.
The logic here is all about being cautious. You have to assume your opponent is smart and will do what's best for them. So each player basically asks themselves, for every move I could possibly make, what's the absolute worst thing that could happen to me? And then, okay, of all those bad outcomes, which move gives me the best of the worst? And this brings us to what's called the maximum-minimax procedure. Sounds a little complicated, but it's not. First, we'll look at the game from Rose's point of view, finding the maximum of her minimum payoffs. We call that her maximin. Then we'll flip the script and look at it from Colin's perspective, finding the minimum of his maximum losses, his minimax. And if those two numbers just so happen to be the same, boom, we've found our saddle point.
All right, here's our game matrix. Let's pretend the rows are Rose's moves and the columns are Colin's. Every number you see is a payoff for Rose. Positive is a win for her, negative is a loss. Colin, of course, has the exact opposite goal. He wants to minimize Rose's winnings. So let's start by thinking like Rose. So for each of her possible moves, each row, Rose looks for her worst-case scenario. If she plays row A, the worst she can do is get a 2. If she plays row B, it could be a disaster at -10. After looking at all her worst outcomes, she then picks the best among them, her maximin. In this case, that's 2. This is her safety net. Rose knows that no matter what Colin does, she can guarantee she walks away with at least 2.
Okay, now let's switch gears and put ourselves in Colin's shoes. For each of his moves, each column, he's looking at the maximum damage Rose could do to him. This is his worst-case scenario. If he plays column A, the most he could lose is 7. If he plays B, it's 8. His goal is to keep this potential loss as low as possible.
So Colin looks at his worst-case outcomes, 7, 8, 2, and 5. What's he going to do? He's going to choose the move that has the minimum of those maximums, his minimax, and that number is 2. By choosing column C, Colin can guarantee that Rose wins no more than 2. And there it is. Did you see it? Rose can guarantee a win of at least 2. Colin can guarantee she wins no more than 2. Their super cautious strategies have led them to the exact same number. And that means 2 is our saddle point. It's the stable, rational, predictable outcome of this game. Okay, so finding the number is cool. It's a fun little puzzle. But what does it actually mean? Why is this single point so critical? And what does it tell a smart player they should do? Well, this brings us to a core idea called the saddle point principle. It's pretty straightforward. If a game you're playing has a saddle point, a rational player should play the strategy that leads to it. It's not just some interesting feature of the game board, it is the solution. This point represents a stable equilibrium. And what does that mean? It means that once both players are there, neither one has any reason to change their move all by themselves. Think about it. If Colin is playing his saddle point strategy, Rose can't do any better by switching hers. And if Rose is playing hers, Colin will only do worse if he decides to move. They are locked in. It's the most rational outcome. But, of course, not every game is this neat and tidy. What happens when there isn't a perfect point of stability? When you run the numbers and no saddle point exists? This is where strategy gets really interesting and dynamic. Check out this game. If we do the exact same procedure, Rose can guarantee herself an outcome of at least 0. That's her maximum. But Colin, he can only guarantee that he'll keep her winnings down to 2. That's his minimax. See the problem? Their guarantees don't line up. The numbers don't match.
And that is the fundamental difference right there. When the maximum equals the minimax, the game is stable. It's predictable. But when they don't match, the game becomes unstable. Rose knows she can get at least 0, and Colin knows he can limit her to 2, and that whole space between 0 and 2, well, that becomes a strategic battleground. The contest is wide open.
And this leaves us with a really fascinating final question. If there is no single best move, no stable saddle point to settle on, how on earth should you play? Well, the answer involves something called a mixed strategy, where you start to randomize your moves. But that's a whole other puzzle for another time.